Welcome everyone. We have looked at slope point form of a line as well as slope intercept form of a line.
Oh my gosh, these are so specific. I wish there was just a more general form.
Well, Ms. T, look at the section title here.
Oh, 7.8, general form of a line. Cool.
Yeah. Although it actually is pretty specific.
Oh my goodness, when will it end?
Probably never. If we look at the requirements for the general form of a line, we're generally looking at having all variables and constants on the same side of the equation and then nothing on the other side.
So like something equals 0?
Yeah, just like that.
Cool.
We'll also only use integer values. So we won't have fractions, we won't have square roots.
Or decimals.
And we will have a positive leading coefficient. Leading? What does leading even mean? Probably that it comes first. So whatever the first coefficient we see is, that one will have to be positive. As such, we define the general form of a line as ax plus by, that looks like a 13. by plus c equals 0 when there are some requirements on that. So where a, b, and c are elements of the integers.
Oh, so these are just numbers, not extra variables.
Yeah, just placeholders for now. If a is our first coefficient, then we'll say that a has to be at least 0. And the greatest common factor of A, B, and C is just 1. So they don't share any common factors. They won't all be multiples of 2, or they won't all be multiples of 3, so on.
And if they were, we could divide both sides by that greatest common factor to help reduce it.
We sure could.
So what we're going to do is we're going to look at these couple examples, couple of examples, and we are going to see why these ones aren't in general form, just to kind of help wrap our heads around it. So, looking at A, why isn't this in general form? Well, it broke that first rule. We need to make sure that everything is on one side, and then the other side equals 0. So, not all terms are on one side of the equation. If we did want to make this into general form, we'd move that 7 over and we'd go 2x plus 3y minus 7 is equal to 0. And that would be much more beautiful. Let's take a look at B. Well, we've got everything on that one side, and we have equal 0. What we don't have is that our A, B, and C terms aren't all our integers. So, coefficients, boop, 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 A, B, and C would have to be integers. And we could do that by multiplying all of these by 10. Right? That would get those decimals into integers. Look at the last two. Take a look at your own. See if you could try these by yourself. Wonderful. You just did that. I'm so proud of you. Okay, taking a look here. Ooh, we've got everything on the left-hand side. Our coefficients are all integers. They all have a GCF of 1. But our leading coefficient, coefficient must be, A is greater than or equal to 0. Our A value would have to be greater or equal to 0. We could fix this by moving all of our terms to the other side or multiplying everything by minus 1. Last but not least, we've got everything on that one side. We've got the equal 0. Life's pretty good. We've got our positive leading coefficient, but not all of our coefficients are integers. We have this fractional coefficient. So not all coefficients are integers. And we could fix this by saying, let's multiply this whole thing by 2.
Now that we know how to spot what makes something not in general form, we're actually going to fix those things. We're going to convert each of these equations into general form. I triple dare you to try it because you can and see what happens. Here I note that we don't have everything on the same side. That y is just dangling about over there. I'm going to subtract y from both sides so that one side just has 0. Therefore, on the left side, I just have 0. On the right side, I still have 2x, and I still have this plus 3, but I also have the subtraction of y. And that one's done.
Keep in mind that order is important. We couldn't have 2x plus 3 minus y. We want to maintain that order. And notice that Mr. A moved over that y because he noticed the coefficient of x was already positive, right? So we want our coefficient, our leading coefficient, to be positive, so might as well move everything to that side if it already is positive.
J'agree. We put that into action in a case like this. So again, I could subtract y from both sides, and that would solve the problem of not having everything on the same side. But instead, noticing that x's coefficient is negative here, I'd rather punch that to the other side. So I'd rather add 3x and subtract 4 from this side, add 3x and subtract 4 from this side, so that on the left side, I'm saying 3x plus y minus 4 equals 0. So it doesn't matter if we say something equals 0 or 0 equals something. Either way, we're equating 0 to something else, and that is A-OK.
Let's take a look at the next one. Here, we notice that, yes, not everything's on the same side, but we also have fractions. My go-to plan is to get rid of that fraction first. And how I do that is I multiply both sides by the lowest common multiple of all of my fractional coefficients. So here I only have one fractional coefficient, so the lowest common multiple is going to be 3. So I'm going to multiply both sides by 3, just to get rid of that fractional coefficient. So I get 3y is equal to negative 2x plus 3. And now I could choose to move things over to the other side. Because my coefficient of x is negative, I'm going to add 2x to both sides, which means I'm also going to subtract 3 from both sides to move everything from the right to the left. So I end up with 2x plus 3y minus 3 equal to 0. Wa-chow! All right, this one here, we have a similar situation. Please try this one on your own. See what you can do. Again, I'm going to start by multiplying both sides to get rid of that fractional coefficient. This time I'm going to multiply everything by 7 because that's the lowest common multiple of all of my fractional coefficients there. And so I get 7y equals negative 3x minus 14. Again, I have this negative coefficient on my x, so I'm going to add 3x so I can scoot it over to make it positive. And I'm going to have to do same with my 14 to ensure everything's on one side. So I get 3x plus 7y plus 14 is equal to 0.
4 more examples on this page. I triple dare you to try them. I quadruple dare you to try them.
Ooh, do it.
Yeah. Well, assuming you've tried them, here I go. My first step is going to be to multiply everything by 5, get rid of that fractional coefficient. and then get everything onto the same side. 0 over here, I still have a 4x, I still have this 10, but I'm also subtracting 5y. Whoop! Here's this one. Again, I'll get rid of those fraction-y fractions, so multiplying everything by 2 gives me that. And then scooting everything to the same side. Got my negative x over here, so I'll move that to the other side. I'll have an x. I'll have the positive 2y, it was positive on that side. And then 8. Switching sides means it switches signs. And that's equal to 0.
All right, taking a look at this one, we might notice, hey, we still have fractions we've got to get rid of, but now we're in slope point form. How does that change? It really doesn't. We're going to start by multiplying both sides by 5 to get rid of that fractional coefficient. So we end up with 5y minus 10 is equal to 2 times x plus 1. Notice because this whole thing's a multiplication statement, by multiplying this whole thing by 5, we do not have to distribute to every single term because that is what this guy will be doing later on anyways. So by just saying this 5 times 2/5, we are appropriately distributing or multiplying that negative 5 to get rid of that fractional coefficient. So here I'm now going to distribute this 2. So I get 2x plus 2. And now I'm going to scoot things over. I want everything over to my right-hand side because my coefficient of that 2 is already positive. So I'm going to subtract the 5y, and I'm going to add 10. So I get 0 is equal to 2x minus 5y plus 12.
So it's worth noting that Ms. T's first step was to get rid of this fraction-y fraction. And for me, that would be the same step if we're really being honest. I like to get rid of fractions if I can. You can also do the distribution step first. So Ms. T's second step was to distribute the 2 over here. You can change that order around. You can distribute the 2 and open up the brackets first if that's the thing that's bugging you most. And you want to get rid of those brackets first and deal with that. Cool, you can do that first. Just as long as you handle all of those things at some point.
All right, try this next one on your own. All right, great, you've done it. Sweet. So I'm going to start by multiplying both sides by 3 to get rid of that fractional coefficient. So I get 3y minus 3 is equal to negative 4x minus 8. And I'm going to distribute that negative 4, so I get 3y minus 3 still on that left-hand side is equal to negative 4x plus 32. And now I'm going to move everything to the left-hand side because I can see that my coefficient on my x is negative. So by moving everything over, I'm going to end up with a positive 4x, still maintain that positive 3y I have on my left side. Now I am subtracting 32 from both sides there, meaning I'm ending up with negative 35 equaling 0. All right, I'm going to give you one really quick bonus example just so that we could see what's going on here. Say, for example, we had 1/2 x plus 2/3 y plus 7 is equal to 0. Right? We can see that everything's on the same side. The only issue really here is that we have our fractional coefficients. Before I mentioned that, when we have those fractional coefficients, we're going to multiply both sides by the lowest common multiple, the LCM of all of our denominators, right? Because typically you would look at this and you go, okay, well, I'm going to multiply this by 2 because I have a half. Right? The 2 would undo this fraction, but it wouldn't undo this fraction. Right? And same ideas. If I multiplied both of these fractions by 3, this guy would turn into an integer, but this guy wouldn't. So we're going to multiply both sides by the lowest common multiple. In this case, the lowest common multiple is 6. By doing that, I end up with 6 halves, which is 3, plus 12 thirds, which is 4y, plus 6 times 7, which is 42, equals 0 times 6, which is 0. So here, if we have multiple fractional coefficients and they have different bases, we would multiply both sides by the lowest common multiple. All right, that is it. That is all. Here is some textbook questions that you can try out.
Nice!
Otherwise, we hope you have a fantastic day!
In fact, have a whole fantastic 2 days. Maybe even a week.